Every few decades, the universe would break its own rules in ways that forced scientists to stop, stare at their equations, and admit something deeply uncomfortable. Our understanding of reality was wrong, again. Modern physics often looks like a smooth, logical story, as if humanity slowly uncovered the laws of the universe piece by piece. But the truth is messier. Many of the biggest discoveries didn't confirm what scientists believed. They destroyed it. Time and time again, nature revealed phenomena that simply should not exist according to the physics of the time. Yet they did. And every time that happened, the entire foundation of science had to be rebuilt. These are some of the discoveries that forced humanity to rewrite the rules of the universe. In 1887, two physicists named Albert Michelson and Edward Morley set up one of the most precise experiments ever attempted. At the time, scientists believed space was filled with something called luminiferous ether. The idea sounded reasonable. Light travels as a wave, and waves normally move through a medium. Sound moves through air. Ocean waves move through water, so light must move through something too. That invisible substance, ether, was thought to fill all of space. Michelson and Morley built an incredibly sensitive device designed to detect Earth moving through this cosmic medium. As our planet orbited the sun, it should have been drifting through the ether like a boat moving through water. That motion should slightly change the speed of light depending on direction. Their experiment was designed to detect that tiny difference. Instead, they found nothing. No ether wind, no change in light speed, nothing at all. The result made no sense. According to the physics of the time, the ether had to exist. But the universe refused to cooperate. For nearly 20 years, physicists struggled to explain the result. Some tried to patch the theory with complicated adjustments, but one young patent clerk looked at the problem differently. Maybe the experiment wasn't wrong. Maybe the assumption was. In 1905, Albert Einstein proposed something radical. There was no ether at all. Even stranger, the speed of light was always the same, no matter how fast you were moving. That single idea shattered centuries of physics and led to special relativity, where time slows down, lengths contract, and mass can turn into energy. All because an experiment failed to detect something that everyone believed had to exist. But the universe wasn't finished rewriting the rulebook. In the early 1900s, another mystery appeared, this time involving atoms. Physicists believed they understood energy pretty well. According to classical physics, energy should behave smoothly, like a dimmer switch gradually increasing brightness. But when scientists studied how heated objects glow, the math produced something terrifying. The equations predicted that hot objects should emit infinite energy at short wavelengths. Infinite. Obviously, that wasn't happening. If it were, a warm stove would release enough radiation to vaporize the planet. This became known as the ultraviolet catastrophe, and it meant classical physics was catastrophically wrong. In 1900, a German physicist named Max Planck made a desperate mathematical trick to fix the problem. He assumed energy wasn't continuous. Instead, it came in tiny, discrete packets, little bundles, quanta. At first, Planck treated this as a convenient mathematical fix, but the idea refused to go away. A few years later, Einstein used the same concept to explain the photoelectric effect, showing that light itself behaves like particles. Suddenly, the universe wasn't smooth anymore. Reality was pixelated. Energy, light, and eventually matter all turned out to exist in quantized chunks. This strange new framework became quantum mechanics, a theory so successful it now powers everything from lasers to smartphones. But it also introduced something deeply unsettling. At the quantum level, reality stops behaving logically. Particles can exist in multiple states at once. They can tunnel through barriers, and two particles separated by light years can remain mysteriously connected. Even Einstein hated that part. He famously called it spooky action at a distance. Yet, experiment after experiment confirmed it. Then came a discovery that was even harder to believe. In the 1930s, physicists studying radioactive decay noticed something disturbing. When certain particles decayed, the energy coming out didn't add up. Energy appeared to be missing. Now this was serious. The conservation of energy was one of the most sacred principles in physics. If it failed, enormous parts of science would collapse. For a moment, it looked like the universe might actually be breaking one of its most fundamental laws. But an Austrian physicist named Wolfgang Pauli proposed a bizarre solution. Maybe the energy wasn't missing. Maybe something invisible was carrying it away. Pauli suggested a completely new particle, one with almost no mass, no electric charge, and almost no interaction with matter. A particle so ghost-like it could pass through entire planets without leaving a trace. He called it the neutrino. At the time, even Pauli admitted the idea sounded ridiculous. Detecting such a particle seemed impossible. Yet, decades later, scientists finally built detectors sensitive enough to see them, and they discovered something astonishing. Trillions of neutrinos are passing through your body every second. They stream constantly from the sun, from distant supernovae, and from the early universe itself. You never notice them. They barely notice you. Yet their existence solved the mystery of missing energy and confirmed one of the strangest predictions in particle physics. But perhaps the most unsettling discovery arrived when scientists looked beyond our galaxy. In the 1970s, astronomer Vera Rubin studied how galaxies rotate. According to Newton's laws, stars farther from the center should move more slowly, just like planets in the solar system. Instead, Rubin found the opposite. Stars at the edges of galaxies were moving far too fast, fast enough that they should have flown off into intergalactic space, but they didn't. Something invisible was holding galaxies together. When astronomers calculated how much mass would be required to produce that gravitational pull, the numbers were shocking. Everything we can see, stars, planets, gas, dust, accounts for only about 15% of the matter needed. The rest is something else entirely. Something that doesn't emit light, something we still cannot directly detect. Scientists now call it dark matter, and it appears to make up most of the mass in the universe. Entire galaxies are built inside enormous halos of this invisible substance. Without it, the cosmic structures we see today simply wouldn't exist. Yet after decades of experiments, we still don't know what dark matter actually is. It's one of the biggest unsolved mysteries in physics. And then, just when things couldn't get stranger, the universe revealed another surprise. In the late 1990s, astronomers were measuring how fast the universe was expanding. Since the Big Bang, space itself has been stretching outward. Gravity should slowly pull things back together, meaning the expansion ought to be gradually slowing down. That was the expectation. Instead, the data showed something shocking. The expansion of the universe is accelerating. Galaxies are drifting apart faster and faster. Something is pushing the cosmos outward. Whatever it is, it dominates the universe. Today, we call it dark energy, but the name is really just a placeholder for our ignorance. Dark energy appears to make up nearly 70% of the entire universe. Think about that for a moment. All stars, all galaxies, all planets, all atoms, everything we've ever seen or touched makes up only a tiny fraction of reality. The vast majority of the cosmos consists of two mysterious components, dark matter and dark energy, that we barely understand. In other words, modern physics has mapped the universe and discovered that most of it is still unknown. just how strange they are, it's how consistently the universe surprises us. Every time scientists thought they had reached the final layer of understanding, nature revealed something deeper, something unexpected, something that forced us to start over, and that pattern is probably not finished. Right now, physicists are searching for answers to questions that may once again rewrite the laws of reality. What exactly is dark matter? Why does dark energy exist? Can quantum mechanics and gravity be unified? Is space-time itself fundamental, or is it built from something even more basic? Somewhere out there, another impossible discovery may already be waiting. A measurement that shouldn't work. A signal that shouldn't exist. A result that refuses to match our equations. And when it arrives, physics will do what it has always done. Tear down the old ideas.